Hello, welcome back. This is a video over Unit 6, Section 3 for Math 8. We're going to be talking about powers with the same base. And so our objectives, we want to evaluate powers of the same base through multiplication and division and simplify expressions of powers with the same base. So what we're about to do is a very powerful tool, this will also help make sense as to what we're doing in the last section with zero and negative exponents. So let's talk about the product of powers rule. So the first thing I want to do is I want to think of an example. Okay, and in this example, I want to do, oh gosh, doesn't matter, 3 squared times 3 cubed. Okay, and what I want to do is I want to simplify this and then potentially evaluate it. So what I want to do, if I were to, the only thing that I know how to do at this point is to expand these out. Okay, if I wanted to do 3 squared, that means I'm doing 3 times 3. Okay, and then if I'm doing 3 cubed, then I'm going to multiply by 3 times 3 times 3. Okay, and so what I've done is, I'm just multiplying. Okay, I'm multiplying 3 squared times 3 cubed. So when I expand all that out, I'm multiplying 3 by itself 5 times. And what I can then do is I can then write this as 3 to the 5th power. Okay, so let's look at that, and let's do another one. Okay. Let's say I've got an example here where I've got, 4 to the 3rd power times 4 to the 4th power, okay? And if I do 4 to the 3rd power, then what I'm doing is I'm really doing 4 times 4 times 4, okay, and multiplying each of those. And then if I'm doing 4 to the 4th, I'm multiplying 4 by itself 4 times in that one, okay? So I've got 4 times 4 times 4 times 4. All right, I'm going to multiply each of those together. Now, because I'm multiplying 4 by itself all these times, I could just count up all these 4s. So when I look at this, I'm doing 4 to the 1, 2, 3, 4, 5, 6, 7th power, and that's that. So I can rewrite this and simplify this as 4 to the 7th, okay? And you might be seeing a pattern here. All right, let's do it with variables, okay? And let's do another example here where I've got, say, x squared times x to the 4th, okay? And if I do x squared, then I'm really just doing x times x, and then I'm multiplying that by x to the 4th. So if I do x to the 4th, I'm doing x times x times x times x. Okay, and so what I'm doing is I'm going multiplying x by itself 1, 2, 3, 4, 5, 6 times. Okay, so I can really write this as just x to the 6th. So you're probably wondering, hey, there's a pattern here. Okay, if I have the same base, okay, here my base is 3, 4, and x. What do I do with my exponents if I'm multiplying them? Okay, and if you look, what do you have to do from 2 to 3 to get 5? What do you have to do from 3 with 3 and 4 to get 7? What do you have to do with 2 and 4 to get 6? And the thing is that when you multiply, all right, so when you multiply numbers with the same base, you add the exponents. Okay, so you add the exponents. Okay, and you're probably wondering, well, why do I have to do that if I can just expand these things out each time? Well, think about it. If I were to do, say, let's think of another example. Let's say I had y to the 150th power times y to the 30th power, okay? And if I'm trying to simplify that, then I don't want to write out y 150 times. I don't want to write out y 30 times and then count. That's a waste of time. But what I can automatically do because of this rule is I can then go y to the 150 plus 30 power, which is going to give me y to the 180th power, okay? And that's why we do that, okay? We have these rules so that we can do things more efficiently, okay? So, going back to these examples here, if I were to come in here and say, rewrite this 3 squared times 3 cubed, I could simply write this as 3 to the 2 plus 3 power and just add my exponents, and that's going to give me 3 to the 5th, okay? I could do the same thing over here and do this problem as 4 cubed times 4 to the 4th, and simply just add my exponents and do 4 to the 3 plus 4 power is equal to 4 to the 7th, okay? If I do x squared times x to the 4th, all right, then I could simply just have x squared times x to the 4th, and that would give me x to the 2 plus 4 power, which would give me x to the 6th, okay? And so that's the rule, okay? And that's the rule down here, all right? So when you read this, okay, product of powers rule, when finding the product of two powers with the same base, simplify the expression by adding the exponents, okay? And so here's your rule, and this rule will work for any number, all right? So if I have a to the m times a to the n, my a is my base, m and n are my exponents. Notice how a is the same. Then all you do to simplify that, you would just add your exponents, okay? So let's quickly come over here and do this, okay? Now you can have negative exponents and zero exponents as well and evaluate this, okay? But since I have 1/3 raised to 1/3 to the 9th times 1/3 to the negative 5th power, if I'm simplifying this, all I have to do is take 1/3 and raise it to the 9 plus negative 5 power. And that's really 9 minus 4, which gives me 1/3 to the 4th power, okay? And I'm just going to leave it like that. You can evaluate that if you want, but we don't need to. Now down here, okay, we can do this problem a couple different ways. First of all, we know that anything raised to the 0 power is 1. So we could really rewrite this as negative 7 cubed times negative 7 to the negative 2 power, okay? And so what we can end up doing here, all right, we can just add our exponents. And so this is really negative 7 to the 3 plus negative 2 power, which is going to give me 3 plus negative 2 is 1. So this is really negative 7 to the first power, and you can just really simplify that down to just negative 7, and that would be your answer, okay? So that's the idea. All right, so that's the product of powers rule, okay? And this is a pretty long-winded way for me to explain that, so you simply just add the exponents, but I want you to see the structure and how we discovered that, okay? And that's why I do that. All right, now we're going to talk about the quotient of powers rule, all right? So let's think of an example here, and let's do, let's do 3 to the 5th power divided by 3 squared, okay? And so what I want to do, if we're dividing, okay, let's expand this out, see what we know, and try and figure out a rule, okay? Let's develop the rule. So 3 to the 5th means I'm doing 3 and multiplying it by itself 5 times. So 3 times 3 times 3 times 3. I'm having trouble writing my dots. It isn't registering, so I'm struggling today. It's kind of a personal thing, but sorry you had to hear that. Okay, 3 squared on the bottom is 3 times 3. Okay, now what I want to look at is I've got 3 divided by 3 and 3 divided by 3. Okay, and what happens here, when I do 3 divided by 3, that divides out to 1. Okay, so these are going to divide out to 1, and what I'm simply left with is 3 times 3 times 3, which is going to give me 3 cubed. Okay, so 3 to the 5th divided by 3 squared is going to give me 3 cubed. Okay, let's take a look at the next one. Okay, Let's do another example. And let's think of 4 to the 7th divided by 4 cubed. Okay? And so let's expand this out. All right? And let's get 4 times itself 7 times. 4, 5, 6, 7. Okay, put your dots in there to show that you're multiplying. And then divide that by 4 cubed, which is 4 times 4 times 4. Okay, and the same thing's going to happen. I can divide out 4 divided by 4. That's just going to become 1. So 4 over 4 is 1. 4 over 4 is 1. 4 divided by 4 is 1. And you're left with 4 times 4 times 4 times 4. You're multiplying 4 by itself 4 times, and so you get 4 to the 4th power. Okay, and that's that. All right, let's take a look at one with variables. Okay, so let's take x to the 6th divided by x squared. Okay, and so when I do division here, same thing. X times x times x times x times 1, 2, 3, 4, 5, and 6. Pick up sticks over x times x. Okay, and so what I have is these things are going to divide out. X divided by x is 1. Something divided by itself is 1. And so you're simply just left with x to the x times x times x times x. And you're multiplying x by itself 4 times, which just gives you x to the 4th power. Okay, so you're probably sitting there wondering, all right, well, there's another pattern here. Okay, how do I use the numbers 5 and 2 to get 3? How do I use the numbers 7 and 3 to get 4? Okay, how do I use the numbers 6 and 2 to get 4? All right, and so what I want you to know here is that you're going to subtract your exponents if you're dividing them. So subtract exponents. Okay, and put a big old star next to that. And up here, let's just put that you add exponents. Okay, and those are the big takeaways from this. All right, so now, and it begs the question, what if you had the example of y to the 180th power over y to the 150th power? I don't want to expand this out and write y 180 times. I don't want to write y multiplied by itself 150 times. But what I can do is I can simply just write y to the 180 minus 150th power, and I get y to the 30th. Okay, and I can just do that very quickly. All right, and I can do the same thing over here. All right, if I redo this and rethink about it, 3 to the 5th over 3 squared is really 3 to the 5 minus 2 power. And I'm just operating within my exponents. 5 minus 2 gives me 3, so I have 3 cubed. I'm not writing as much, okay? And it's a lot faster for me to do this, all right? So if I've got 4 to the 7th over 4 cubed, then that's really 4 to the 7 minus 3 power, which is 4 to the 4th, okay? Same thing here. Okay, I can do x to the 6 over x squared, and I can just rewrite this as x to the 6 minus 2 power, which gives me x to the 4th. Okay, so however you want to do it, doesn't matter as long as you get it right, but it's a lot easier to do this. Okay, so this is the rule down here. So when finding the quotient of 2 powers with the same base, simplify the expression by subtracting the exponents. So if I have a to the m over a to the n, I just get a to the m minus n power, and a can't be 0, can't divide by 0. But let's simplify this guy. Okay, find the quotient of this. 5 to the 9th over 5 to the 6th. All I'm going to do is write this as 5 to the 9 minus 6 power, which gives me 5 cubed. Okay? And you can evaluate that if you want. I'm just going to leave it like that, but that's the idea, okay? I don't have to write out 5 multiplied by itself 9 times. You can do that if you want, but just use the rule. It's a lot faster. It's a lot easier, okay? All right, let's take a look at the next page. All right, so let's do a couple of these problems, apply these rules. In this one, I can do this one a number of ways, but I'm going to do it both ways, actually. I'm going to first use the quotient rule, okay, and I'm going to write this as negative 5 to the 0 minus negative 3 power, which is really going to give me negative 5 to the 0 plus 3 power, which gives me negative 5 cubed. Okay, and that's that. Now let's try this, all right? If I wanted to do it a different way, negative 5 to the 0 over negative 5 to the negative 3. First of all, I know that anything raised to the 0 power is 1. So I'm going to write as 1 over negative 5 to the negative 3. Now remember, if I have a negative exponent, all I got to do is move it up across my fraction line, and I can just write this as negative 5 to the third power, okay, over 1. All right, and that's our answer, okay? So two different ways you can do this, and that's what's kind of cool about this. Working with exponents and simplifying these, you can kind of do whatever you want, all right? It doesn't matter, okay? Now, ooh, I like this one. So let's do this, all right? Let's use our rule here, and we're going to talk more about something like this, all right? So if I do 12 to the 4th over 12 to the 6th, I'm going to write that as 12 to the 4 minus 6 power, which is going to give me 12 to the negative 2 power. I'm going to put that over 1. Remember, our negative exponent means that we need to bring it down into our denominator, and we're going to get 1 over 12 squared, okay? And that would be our answer, okay? So even though you would get this by using the quotient rule, you'd want to write it as a positive, with positive exponents. Okay, now here, all right, you could do this a couple different ways, but let's do this using the quotient rule. So y to the negative 2 minus a negative 5 really means that I've got y to the negative 2 plus 5, and so I get y to the third power, okay? And so I'm just simplifying it using that. Now, if I wanted to, what I could do from our last lesson is I could take each of these, move them across, and rewrite this as y to the 5th over y squared. And then I could just go y to the 5 minus 2 power, which gives me y cubed. So it doesn't matter how you skin that cat, but it does matter that you get the right answer in the end. Okay, so you can do these multiple ways, but it doesn't matter. Okay, so let's talk about. I'm going to skip this problem here and talk about using the product rule and quotient rule to find the negative and 0 exponents, to kind of explain that, okay? So let's think about this. Let's talk about the 0 exponent, okay? And so this is how I typically explain how you get a 0 exponent. But let's say I have this. I've got this problem. Let's say I've got, I don't know, 3 squared divided by 3 squared, okay? What you have to think about is something divided by itself is going to give you a value of 1, okay? Now, if I apply my quotient rule and I do 3 squared over 3 squared, and I write that as 3 to the 2 minus 2 power, all of a sudden I get 3 to the 0, okay? Now, what I want you to see is that I thought about this problem 2 different ways, and I get 2 different answers. But what we need to realize here is that 1 and 3 to the 0 are the same thing. Okay, and I can write this as 3 to the 0 is equal to 1. Okay, and that's our rule. Okay, and that's how we get that. All right, so you can look at this a couple different ways, but I like using the rules because it kind of helps you. Okay, let's do the negative exponent, which we kind of did up top. Let's do 3 squared over 3 to the 5th, okay? And let's do this 2 different ways. The first way I'm going to do it is I'm going to expand this out. I'm going to do 3 times 3 over 3 times 3 times 3 times 3 times 3, okay? And so what I end up getting here, by expanding this out, I can divide out my 3's divide out, and I'm left with a 1 in my numerator. Okay, 3 divided by 3 is 1, so these are, really replaced by 1s here, okay? If you got questions over that, please let me know. And then I have 3 times 3 times 3 in my denominator. So I have 3 times 3 times 3, which is going to end up just simply giving me 1 over 3 cubed. Okay? So I do it using the expanded method, and I get a positive exponent out of it. Now, if I do it the other way, which is the one we just did in that previous problem, if I have 3 squared over 3 to the 5th, then what I'm doing here is I've then got 3 to the 2 minus 5, which then gives me 3 to the negative 3 power. So when I'm doing these problems, I'm doing them 2 different ways, getting 2 different results. Therefore, what this means is that those are the same. Okay? And so what I can then say is that I've got 3 to the negative 3 is the same thing as 1 over 3 cubed. Okay? And so, to get this, to be positive, I just take this value, move it down to my denominator, and make my exponent positive. Okay? And that's the idea. So I can, I like this way best of explaining how you get 0 exponents and negative exponents and why this works. I just think it's a cool way to show it. So hope you enjoyed this video. We'll talk to you soon. See you later. Bye!